Hello everyone, I'm really thrilled to be here and to talk to you about our experiences with cryptocurrencies, AI, and a little interesting story, what happened, what we found out, what worked, what did not work. So this talk will about be the use case, how we applied everything, and if you have questions in between, just raise your hand. I will try to pull them in the moment when they come, and if the answer is too long, then we will do that at the end. So first question to all of you, who of you owns Bitcoin? Oh, that is really less than I expected. Do you only own Bitcoin? Let's start different. Who did hear of Bitcoin here? Okay, so that is better. There is not only Bitcoin, there are now, I think, 1,300 different cryptocurrencies competing for the market, that the people invest into it. We are talking about 150 plus exchanges, like the stock exchanges, where you can trade cryptocurrencies against each other. So that means you can sell your ripples for Bitcoins and change your ripples into Ethereum and so on and so forth. And people have the idea, I build a new currency, and then they push the new currency to the market, set up a Twitter account, tweet about it, and motivate the people to buy their worthful or worthless currency, depending however you see it. And our idea was, can we use social media data, in that sense Twitter, to predict the exchange rates of cryptocurrencies? And frankly speaking, when we started that, we did not know if it will work at all. Because is there a relation between social media and cryptos? We did not know. We had one paper. The paper was about predicting the stock market by social media mentions. And that showed, and there they provided so-called evidence that it's possible to do it. So we thought, okay, it should be possible for cryptocurrencies as well. But before I start, one short background about me. My background is mainly software engineering and architecture. That is what I wrote my PhD about. It was about how to structure a program right, and how to structure a data-driven program, and how to analyze data structures in a program. So I'm a mixture between business intelligence, when you go back into the years, and software architecture. And I'm glad that big data now allows me to fusion these two souls that I have in my body, to say I can create big data architecture and analytics at the same time. Aside that, I believe in the blockchain stuff. What does not mean that I believe in cryptocurrencies. I believe in the technology, that there is a need for distributed ledgers in several use cases, not in all the overhyped things. And I believe that in the future we will do data trading. And I believe that we will trade the data, that we can train AI models, and that will happen over blockchain. And here's my contact, but you can also reach me over Xing or LinkedIn. So, since only 2 of you heard of Bitcoin or more, we have, how does that work? That is the process. Someone sets up a blockchain project, and then someone publishes news about this project and yells it out, and then you have a lot of news. And the crypto community, that means the disciples of the currency, then re-emits or retweet the news about the cryptocurrency. Or they also create news that somebody is getting out of the project. So there was, for instance, a tweet of the Litecoin founder. That's a really huge cryptocurrency. And the Litecoin founder said, I do not hold any Litecoin at all. What led to a total crash of the currency for a short moment. And then he said, I do not hold the currency because I'm afraid of the SEC. Because when I tweet, I do insider tips and so on. So I don't own the currency. And then it was rising again. So there is a huge interaction. And out of that news, and the blockchains, the different projects and lists into these exchanges. Nowadays we have 150. I think it's past a few weeks now. I think there are now more. And this these exchanges are, they have transactions in the amount of billions, how people exchange such coins. It's really huge. Before we started that, we thought, okay, there are a few people jumping around and trading Bitcoin, but the news and everything that's generated is such a massive amount of data. So, and the news then influence the traders, and finally the traders trade based on the information. So, what was the requirement to build machine learning to predict then how does a currency behave on the exchange? Can we predict 1 hour? So we said there are 150 exchanges and they all behave differently. So we need to set up an architecture where we can exchange the exchanges because we do not know if it works, and if one exchange does not work, maybe our approach works for another exchange. We did even not know which machine learning algorithms that we should use because of problem 1. So we said we need to have an easy possibility to change the algorithms and to see what works and what does not work. Then there is one reality that is quite awkward. Maybe somebody tweets at one time and it has a correlation to the price of the cryptocurrency. But maybe somebody just tweets sometimes and the price does not do anything. Or somebody tweets and say, there is really bad news and nobody cares, nobody trades at all. So we need to grasp that moment when one says, the world is ending here. And all the other traders react and say, the world is ending. Because it does not help us when we have a situation where someone yells it out, the people retweet it, and there is no implication for the market. So we have to correlate that very moment to say we do not want to predict every exchange move. We want to predict the certain exchange move as when we are relatively certain that an exchange move will happen. And to make it a little bit more ugly, we said, okay, maybe we have different coins. That means a different amount of people who tweet about coins. So you all have heard of Bitcoin, maybe you all have heard of Ripple, maybe you all have heard of Ethereum, but I guess nobody has heard of Sumo Coin, Nano, and what is else there? There are a lot of them, okay? So we said we take the top 100 and maybe they behave differently because there is different noise and so on. And then we said, okay, we should be able to hot plug different algorithms because when we do that, maybe it works on one day and the model is valid, but maybe on the next day a model is not valid anymore and another algorithm is performing better. So we should be able to separate the process to do learning at one time and examine if the learning is running valid, what is the current state of the model, but also to say, oh, we maybe should switch now to a new model. That correlates with the last thing, that models change over time. The volume changes. At the beginning of this year, people have been crazy about Bitcoin. It was at 20,000 euros or so. But nowadays, there is no interest anymore. So it changes completely. We cannot use the data from January or last December to predict the current December. There is no way. There is a different noise. And then we said we should do trading and prediction in parallel. So how do we build that? We have the requirement to switch to different algorithms in production. We want to train and evaluate the model that is currently doing the prediction, because when I want to do a trade on the model, I have a prediction that says I have a likelihood of 70% this coin rises, and I have that prediction. Then I need to know how valid is this model. How valid are the last 100 predictions of that model? Can I rely on that? And then so what is not possible, that we deploy everything, that we model it, that we examine the data, and we take all of the data in a static way, push it into an Hadoop, build a model, and deploy it to the production system. Okay, that could be automated, but we said that is not our goal. We want that it's built in a way that we slice it not in the monolithic way. Because when we ingest data from Twitter, maybe we need to, you have two data streams. You have the Twitter data stream, and you have the data stream of the exchange, what the people offer and ask for when they sell a currency. You marry these two streams. And once you've married these two streams, then you use this as training foundation. Thing is, what happens if you say my service that is ingesting Twitter data, that is examining Twitter, needs an update? And you want to develop that in an agile way, and you say, I have continuous deployment. I have an update. I improve the data that I get from Twitter. I have new keywords that I use. So you need to deploy the Twitter ingestion separately to the exchange rate ingestion to then marry these two streams, and that means you have to deploy them as microservice, and you have to do it in an agile way. And then you have continuous deployment, and that is why a monolithic deployment does not work in that way. So let's go back to our friend here. Who knows that guy? This is Dijkstra, and Dijkstra invented separation of concerns. And what Dijkstra said is, study one aspect of a system in isolation to come up with an architecture that is quite modular. That is how we build generally our big data projects, that we say, what are the aspect how we want to slice the system down. And what we took as aspect is, how are the data streams coming in? We say, there is a data stream that is Twitter. From that data stream, we can detect the different currencies. So we partition the holistic data stream of Twitter and say, there is whole Twitter, and then we say one partition is Bitcoin, one partition is Ethereum. So we can fork that stream based on the different currencies. And that different streams that we have then can be subsequently, everything that happens can be done in parallel. Then we analyze each of the streams and say, is it positive, negative, or neutral? And then we have different windows, time windows. Well, that means we have the time window of what happened in the last 30 minutes, what happened in the last hour, and what happened before. So we know this is the current state where we are now, but we also know what happened half an hour before. And that half an hour before is exactly what we need for training, because we have currently, at this very moment, the exchange rate that is the result of the half an hour before. But the future we do not know yet. So we can say, when we split that into different time windows, we have a training stream of the history, what happened, and we have a stream of now. And now stream is used for prediction, and the training stream is used for training. So now the process how to do that, what I explained, is we use the exchanges. We here also separate partition between the different cryptocurrencies. Then we split it into the same time windows, like the Twitter stream. Then we compute the change that happened in the past and use that change together with the older window to train the model. That state of Twitter with that sentiment led to this result, and that we feed into the model. Regularly, we copy the model and use the same model to predict the future in the same moment. So we have that here gives us the data stream. This here is the model that we are training. We copy that model and use the same model to predict then with the current window. Let me show this in data because that is more easy. So we have time windows and we have the amount of tweets, we have the tweeting persons, we have the market capitalization at that time, we have the tweeting persons per market capitalization, and we have an exchange rate. And we have that for the past, and we have that for the future. And that is what we use as a training set, with a few extras of data. There are more dimensions than that. That is simplified what we have.
What do you mean we have this for the future?
So you have to imagine that here, okay? You have a market capitalization at 1600, okay? So you know that this amount of tweets and this amount of tweeting persons and this amount tweets, positive, negative, neutral, led to a certain market capitalization at 1600. Okay?
Also looking from the X perspective.
Yeah. Okay. So, in order to make that more complicated, we now have that streams, and we have to train models, and we have to train different models for different algorithms because we do not know what works. So now we have the viewpoint. We have a data stream for one cryptocurrency, and we then train different models. And there we train the model, and then before we train it, we also say we know the result of the training set. So we test if we would predict the right way. And then we say, okay, it was right or it was wrong. Then we can say how many different predictions were done in the right way. That we say, and that is then a stream. We continuously get data out of it. We continuously get, I did the right, my prediction would have been the right way. Now I trained, and now I'm a bit better. So we test the fitness of the model continuously, and there is a data stream that we then need to consider before we finally train on that. So we need to collect the statistic of the health. Is it feasible, the model? Is it good or is it not good? And out of that, we can say which of the different models was performing best in the last half hour, in the last hour, in the last day. And that model we then use for the prediction. So that gives you a complete known component because you need to inspect the model continuously. What did we do in a software way? We said we use microservices to ingest the data, and we try to build that in a Kappa architecture way. That we say, who of you knows the Kappa architecture and Lambda architecture? So simplified, in big data you have two architectures. One is you have a data stream, and then you dump it down to a database and aggregate it there, and then you have computation that pulls something out of the database and then does something with the data stream. And the second approach, this is now oversimplified, is that you see everything as a stream, that you say data is only an increment of a stream to reality. That means you have a patch set on the reality. This means you have the commit log, and you look at the commit log of a database. It makes it easier. We can discuss that offline later if you have questions to that. That's no topic. And we said we need continuous deployment. That saved us a lot of a hassle to use continuous deployment, to say that we can just deploy it, and we needed to build this architecture that if a component is going offline, that we can catch up with the past and still get the training data. And that we support the model evolution. And then with model evolution, I mean the data model evolution. So at the beginning, you start that, and everything seems great. You think, that is my model, how Twitter looks like, and which KPIs I use for prediction. So a challenge was really to say, I now introduce a new KPI because I found out I need more or other data. And to model that when you have that data streams is quite complicated. And that everything is processed in a reactive way. That means You have services listening what is happening and then react, and not you do not have a pull approach. It's more a push approach, but the software reacts when something new happens. And then, in addition, this continuous update models that then need to be distributed over different processes. How did we solve that? We used the microservice to ingest data from Twitter. Then we had a database which different currencies we want to extract from there. And that database also did the sentiment analysis. That computation service here used the database to determine which currencies are interesting and then determine the sentiment of the tweets. At the same time, we had a microservice that ingested the data from one crypto exchange. That solves the problem that if one crypto exchange does not work, we just change the microservice that pulls the data from the exchange, and that way we were able to exchange the exchange. Then we had a component to classify that stuff into windows, and that windows then trained the model. At the same time, it sent the data to a microservice that monitored the models. And from that, we had a microservice updating the predictions, the prediction model. And finally, then we had a trading board, an email, and a WebSocket interface that we can send emails that something changes. There is a new prediction. So when you have a microservice for that, and you have a well-shaped API, then this makes it really easy. But I think the most interesting thing is, what did we learn? We were able, depending on the cryptocurrency, to predict. No, the first prediction, I tell you about the first prediction. The first prediction is the most interesting thing. What we did, we found out it does not work. Really found out, and it did not only, it did not work, it completely did not work. Then we tried a different algorithm, and it also did not work. And after a while, we discovered that it's very, very important to consider the time window that we are predicting. Because the research that we found about the stock market was predicting the stock market based on the last 3 days data. And reality is, when you look at 3 days of data and the stock market is going down, the people will get afraid and they will tweet about it. So the question is, does the research about Twitter really and the stock market really say there is a correlation, or does it say that people were tweeting about at the same time when the exchange was falling? Was really social media the clue to predict the future? So we said we need to change the time frame which we regard and which we predict. And after we did that and we experimented with the time frame, so we did not only have different models with different parameters, no, we had in addition different time frames where we can predict or not predict. Then we had a prediction success differing between the different cryptocurrencies between 70 and 90%. Now you ask yourself, why I'm standing here? Why didn't we set the trading board live, go live, and check the revenues? Because this time window that we have, there are trading fees that we have to overcome, and there's a spread. Who of you did stock market trading? Okay, so you know the spread between the bid and ask rate, that you always make a loss, so you have to overcome the spread in your prediction. Then you have to overcome the commission. That would have been more or less maybe okay, but there is one thing in addition: we only were able to predict the exchange rate in relation to Bitcoin. So then you own Bitcoin, and then you need to change Bitcoin to real currency or to USDT or so. And that then will cost you commission in addition. So in fact, it's nice if somebody has no other hobbies and says, I set my life on cryptocurrencies, but for us it was not feasible, and we had people who wanted Twitter data, and we decided, let's sell the aggregated Twitter data to our partners. They are happy with that, and they even don't know what predictions yet, and so that is the story. But it worked pretty well, and Bitcoin did not work, because Bitcoin has too much noise. It was more the smaller coins. When we did that, it's really crucial that you monitor your application. When you build such an application where you want continuous predictions and you want to update the models, it's really crucial. And you have different data streams. You need to monitor where something is going wrong. Because there might be the Twitter API down, you do not get new data, and you need to know that because you do not look into it anymore, you need to know, is my application still working? So logging, health, monitoring, and metrics, how everything is processing is very, very important. And build it for the way that a service can be done. Because even if you do not believe that your Twitter connection will ever break, your hoster makes a maintenance window and the server reboots. So build for that. A microservice can be done. And you then have different relations between different microservices, and that adds a complete new, let's say, connection between the infrastructure, like rebooting of the server to your microservice. But maybe you also want to change your network, you want to change to new services, and then you want to redeploy your software on a different landscape or at a customer's landscape. So infrastructure configuration, when you have containers like Docker, and to save the infrastructure configuration in Git is a really good approach that helped us a lot. And when you do data models like that, and you push the data through your internal microservices and they connect, think about the data models. Think about what happens if we add new fields to the data. How do we want that? That is really a thing that helps you a lot when you think about that before you do that. And then you have things like Kafka topics and so on. Version that stuff. Version that you have the first version, you think you are right, and a few days later you think that you are not so bright at all, and you will have version 2. And model that you can update the different things. At least that is the lessons that we took. So what do we have as a recommendation? If we apply at customers, it's automation, automation, automation. And I cannot say that often enough. If you make things that you want to deploy continuously, try to automate as much as possible, because the human error is always so high. If you think, oh, I just want to deploy the model and I do not need a standardized process, I just want to do that once, you will end up doing it 5 times. Anyway, so try to automate that and to invest the money to go in continuous deployment with everything that you can do. That means automated builds, automated tests, and automated deployments from stage into production. Like that, no human errors, no password math. And most importantly, you still will get it wrong, and then you can do a rollback because you already have an old version, and you can do the rollback. And I think maybe the rollback is already worth it. Then another thing, it's not always possible, but if you create services, make them stateless. That means you know what a state is? Okay. Who knows what a state is? Okay, so your task, who knows what the state is, explain to the ones who do not know what state is after the talk. That is not completely possible all the time to avoid dependencies between microservices, but avoid it if possible. Make them independent, that they are generally usable. With my background in development, I always try to create APIs that are so huge that I can do everything in the future. Don't do it like me. Make it small, make it really for the use case, as small as possible. You will have to maintain it, and you will forget what other people use. That is more also learning from other projects. The API as small as possible, because you will end up not knowing who uses it. And test the APIs, because when you change it, you have automated tests. You combine that with automated deployments, then you can automatically run the tests. And if the API breaks, you see it when the test runs. And you see it when you deploy it. No right-clicking and say run JUnit, no, automate everything like that. And Docker Compose makes me personally happy. You can also use other containers in my opinion, but Docker Compose with nice jar files where then you have at least a certain control what is happening there. And when you deal with microservices, my experience is also that make the stuff that accesses the infrastructure configurable. So even if you build a service where you say, and there was the last German election, we had some partnerships and we analyzed the Twitter mentions of politicians. And we built a microservice for that. And this microservice to get the Twitter data was built in a generic way that we also could use it for different things than politic handles. And that is exactly what we use now to ingest the Twitter data about the cryptocurrencies. But even if it might not pay off at the first time to make it configurable what runs on the infrastructure, like the table names or the topic names, when you have a config file, it's a lot more easy to reuse the stuff. So let me do the summary. I showed how we built this architecture, and the main conclusion, what I transfer knowledge, what I wanted to give you is, when you build such things, if you build a data-driven application, aside of machine learning, also with big data, try to get familiar with the microservice approach and everything, because it eases your life, you can ease deployment, and you can increment much more easily. By the way, who of you is familiar with microservices? Okay, so microservices are, for the rest, are small components that you can deploy independently to an infrastructure and that you monitor, that you do not have a UI. So, for instance, a checkout process in a web shop could be an independent microservice. So you do not build an application at once, but you say, there are different components of the application, and I want to deploy them separately. Then I talked about how did we slice the application down into different microservices or stream processing components, and for that we used the concept of data streams, which data streams do we have and how do they interact, and from that we identified different components that we needed to build this application. When you train your models regularly and you update them, then you need some kind of evaluation monitoring, maybe not even in that online learning approach that we use, but also when we had a talk this morning about the German Railroad and train predictions, and they also updated their models regularly, and they will also monitor the models if they are valid, how good are they, that was also in the talk. So when you update models regularly, you need some control if it is valid what you are training. Software architecture is something that is needed, and I talked about what was our architecture and which different microservices did we use. And then I was getting into what we consider as best practices for us.